first step of the synthesis of epoxycyclohexane involves reacting cyclohexane with NBS using water and acetone as our solvent system. So we'll start by placing a stir bar in a 125 milliliter flask, and then we'll place 12 milliliters of acetone. We have a squirt bottle of acetone. Okay, so we'll place 12 milliliters of acetone. And 10 milliliters of deionized water. So that's our solvent system, along with the 3.5 milliliters of cyclohexane. Now this reaction will be placed on the hot plate, but we're really only using the stir bar function of that. And what we'll need to add is the 7.4 grams of N-bromosuccinimide that we weighed out initially, and we want to be able to add all of it at the same time. Okay, and then we can go ahead and turn on the stir bar. We're going to allow it to stir for about 15 minutes, right? You'll notice that it'll initially have this yellow color, and over the course of 15 minutes stirring the reaction, the yellow color will basically begin to disappear. Okay, so we can go ahead and take the stopper off of the separatory funnel, and we have our reaction mixture. And we'll just take another stir bar to hold this particular stir bar in place and pour the solution. Then we could place the stopper on, and what we'll want to do is, while holding the stopper in hand, we'll invert to mix and vent it out. So the product that we have in solution right now would be trans bromocyclohexanol. Right? Would it be more soluble in the aqueous layer, or would it be more soluble in diethyl ether? Once the layers have separated, we can go ahead and drain the aqueous layer into a flask. Remember, you can add a drop of water and take a look at where the drop of water falls into to decide which is the aqueous and organic layer. You may also look up differences in densities between diethyl ether and water. You want to make sure not to get any of the aqueous layer or drain. Alright, so you want to make sure not to drain any of the aqueous layer. You're going to be able to wash it. You will be washing it one more time with this concentrated solution of sodium chloride. So we'll go ahead and add that. And we'll close this stopcock and repeat the process of mixing and venting. Okay, so we can go ahead and drain the aqueous layer into the same flask as the previous aqueous layer. Okay, so now what we have remaining is the organic layer, and what we'll do is take the separatory funnel and a 50 milliliter flask and we'll use the neck of the separatory funnel to pour the organic layer into a 50 milliliter flask. So now we're ready to add anhydrous sodium sulfate, a drying agent, to the organic layer. Remember, we do store anhydrous sodium sulfate in the desiccator to avoid absorbing any water from air. So you're gonna make sure you close it right away once you open it to remove some to add into the organic layer. We do add a small dime size amount, and if you notice that they're clumping up, it means they're absorbing water and you may need to add some more. Alright, we do see some that are free flowing, not clumping up, so we do not need to add any more. So now that we're ready to start setting up the reflux with dropwise addition, we'll start by placing a jab underneath the hot plate. So when we set up a reflux with dropwise addition, we do want to add a Claisen adapter. It allows us to connect the separatory funnel directly on one end of that Claisen condenser, and on the other end we'll connect it directly to the reflux, or we'll connect it directly to the water condenser, right? So based on this setup, it looks like I need to increase the height of where I'm connecting the condenser to the back wall support. Is add a little bit of grease right on the connection between the condenser and the Claisen adapter. And then we'll add the cat clip as well. Right? Alright, so now my setup is almost complete. I do need to use the separatory funnel, and it'll go right over that part of the Claisen condenser, right? So what I'll need to do is grease the joints as well. Okay, what we can go ahead and do next is take the round bottom flask. We have 100 milliliter round bottom flask. We'll place a stir bar in there, and then we'll place 25 milliliter of 10% sodium hydroxide solution. And then we'll place it, and then we'll just turn it slightly so the grease kind of goes uniformly throughout. And then we'll go ahead and add a keck clip. Okay, you do want to be holding the round bottom flask while you're adding that. So now next what we need is to get a 400 milliliter beaker. We could lower the jack in this case. We're going to go ahead and add the solution from our first step into the separatory funnel. Right, that's the solution that had the drying agent, and you do not want to dispense any of the drying agent. Okay, so now that we've set up everything, what we'll need to do is turn on the water condenser. Okay, and we'll need to turn on the heat source. Right, we're going to allow the temperature to reach 50 degrees Celsius before adding trans bromocyclohexanol into the solution that contains 10% solution of sodium hydroxide. And we do need to gently stir the solution, so we'll turn on the stir bar. Okay, once the water bath has reached right around 50 degrees, we can go ahead and start adding our reaction mixture to the 10% sodium hydroxide solution. You want it to drop slowly so that the solution is added over 30 minutes. So notice both trans bromocyclohexanol is being added dropwise into the round bottom flask, but you may also notice the condensation from the round bottom flask as it evaporates and begins condensing back into liquid. And you do want to keep the temperature right around 50 degrees Celsius. Okay, so now that trans bromocyclohexanol has been added to the solution, we can go ahead and close it, and we'll allow the reaction to vigorously stir under reflux for about 20 minutes. Notice the actual temperature of the water bath is right at 50 degrees, right? And you could see the condensation, right, of the vapors from within the round bottom flask condensing back into it. Okay, so now once the reaction is complete, we can go ahead and turn off the hot plate, the stir bar, and we can lower it off of the heat source as well. Okay. What we'll do is take off the cap clip from the separatory funnel, and we'll slowly take it out, and we'll place it right on the iron ring because we're going to need it for our next step. Okay. We could take off the thermometer and the water bath, and then the round bottom flask will be placed on ice to cool for a few minutes. Okay, now that we've allowed it to cool on ice for some time, we'll go ahead and place it into the separatory funnel, and what we'll do is take another stir bar so that the stir bar doesn't fall into the separatory funnel. Notice the formation of both layers because we had 10% sodium hydroxide solution, right, which was in water, and it was an aqueous solution, and then we had our initial reaction mixture in diethyl ether. So allow both layers to separate. All right, so we can go ahead and drain the aqueous layer into the flask, and in this case the bottom layer is our aqueous layer. Okay, and then what we will need to do is add 20 milliliter of 1% sodium hydroxide to the separatory funnel that contains our organic layer. All right, we'll need to place the stopper hold the stopper in place, and then mix and vent. Right, and then make sure you close it, and then you can place it right back onto the iron ring and allow both layers to separate. Okay, and then we'll go ahead and drain the bottom layer, the aqueous layer, into the flask that contains the aqueous layers. Okay, and we'll repeat this process 2 more times. So we'll go ahead and add another 20 milliliters of 1% sodium hydroxide solution onto the organic layer that's in the separatory funnel. And we'll repeat the process of venting, or mixing and venting, right? So that's the second wash with 1% sodium hydroxide, and then we'll do one more. Okay, so now we can go ahead and drain the bottom layer. Again, that's the aqueous layer in this particular experiment. And then we'll go ahead and add the last portion of 1% sodium hydroxide to the organic layer. We can go ahead and drain the bottom layer. Alright, and in the last step we'll add 20 milliliter of solution of saturated sodium chloride. We'll mix it and let. We'll drain the bottom layer, which again is the aqueous layer in this case. And we'll drain the organic layer into a 50 milliliter flask. And then we'll add drying agent, anhydrous sodium sulfate, to dry out any remaining water in solution. Alright, so I've added a small amount of anhydrous sodium sulfate, and you could, if you could tell from the flask, they're not clumping together, which means that we don't really have water within this organic layer. Okay, what we'll need to do next is decant the solution into a 50 milliliter round bottom flask without really decanting any of the drying agent. Okay, so here's both. Okay, so what we should have in here is our final product, epoxycyclohexane. So what we'll do is use the Rotavap to evaporate the diethyl ether, and then we'll weigh the product that we get.